Today on Xenodilodon, we're going to be doing a little bit of laser surgery. I have 3 of these B&W Tek 473 nanometer DPSS laser heads. However, only 2 of them have drivers. So we'll be connecting the third one up to a different laser driver. The laser driver that I'm going to choose for this is this one right here, which is made for a 500 milliwatt 532 nanometer DPSS laser. So it should be 100% compatible with this laser head here. I'll be using this laser driver to get the nominal current for the pump diode inside of this laser head, and I may push it a little bit to see if we can get a little bit more power output. This one is not in the greatest of condition, so it needs a little bit of love and care. I have the bad 532 nanometer laser that went with this driver here. We'll be using this connector. This laser doesn't work anymore. What happened is the vac lens in front of the pump diode kind of blew up and took out the pump diode, and I don't ever see really replacing that. So, dead laser. For comparison, if we need it, I do have a functioning unit that is identical to this. So if I need any kind of other readings, I have a working unit to pull those readings off. Basically, what we're going to be doing is figuring out the pinout on here. We're going to be removing this connector on this laser head, and we're going to put this connector on in its place. There'll be 5 things we'll be connecting up. The pump diode. There's 2 thermoelectric coolers on the inside of the laser head. One for the laser diode and the other one for the second harmonic generation crystal, which is the LVO. 2 thermistors, and that's it. So the important things is to get the current and the polarity right for the pump diode, to get the polarities right for the thermoelectric cooler, so that way they don't fight the thermistor, and then the correct thermistors correctly pinned out. So the first thing we're going to do is we're going to start with figuring out our pinouts. Now, the easiest way to do that is really to pull apart this laser head. So what I have here, I have the same pins as you would see on the connector here. So just like that. And I'll be labeling which pin does what. Let's get started with that. I'll be using the multimeter to find the lowest path of continuity. And I've already checked the thermistors for the resonant cavity and the pump diode to make sure they're roughly the same resistance, which is 15 kilo ohms. Pull the top off, and let's get to figuring out what the pinout is. And here we have it. I'll point out the parts on the inside. Pretty easy to identify once you know what they are. So here we have the thermistor for the resonant cavity. We have the red and the black wire here, which go to the thermoelectric cooler that's underneath the laser resonator. We have the positive and the negative, could be vice versa. Yeah. Negative and positive for the pump diode. We have in the back the thermistor for the pump diode. I don't know if you can see those wires or not, but we'll pull this out so that way you can see it a little bit more. And then the thermoelectric cooler that sits underneath there. There should be one. Yep, there it is. So, little thermoelectric cooler right here. Go ahead and pull this out so that way we have better access to those wires. And we'll start figuring out what the pinout is. Oh, looks like we're gonna have to pull the outer casing off. Right, that'll be fun. Tools. Actually, you know what? We can probably just leave those in. Yeah, we'll leave that in. Or should we? No. No. Gotta take that out too. Some people do crossword puzzles. I do this. Alright. See if we have access to a thermoelectric cooler or not. Yeah, I just can't win. The one that fits is too wide. Too wide. Maybe. Good as new. Alright, we have reasonable access to everything, it looks like. There's a thermistor here for the pump diode, thermoelectric cooler for the pump diode underneath, the thermoelectric cooler for the resonant cavity, a thermistor wire is here. That looks good. Let's start figuring out what goes to what. So, first let's start with the pump diode. Grab that. I'm going to put it right on top of the block that the pump diode gets mounted on, because that will be one of our connections. Boy, that was easy. Make sure it's not any of the other ones. First try. Wow, that's cool. So we're going to mark that down on our diagram. PD positive. Next is to find the pump diode negative. I'm betting it's the one right underneath that, so let's see if it is. Nope. It looks like it's the one over, so put PD negative. Now let's sort out the thermoelectric coolers. So, first one we're going to try to get a reading on is the thermoelectric cooler for the pump diode. So, let's see what wires that goes to. Okay, that will be the green and the brown. The red goes to the green. See right here, the green and the brown go to the red and black for the thermoelectric cooler. So let's figure out what those wires are. So green first will be the positive. Probably be the upper ones. Yup. Alright, let's make sure it's none of the other ones. Well, that one shares pretty good conductivity as well. I'm betting it's going through the thermoelectric cooler. Okay, so that's 2.2 ohms. That's 0.2 ohms. So I'm going to mark that PDTEC, or PDT positive. Double check. And the next one should be the PDT negative. So over to the brown one. That'll be our negative wire, which should be that one that gave us the 2.2 ohms. We don't want above it. Yes. Making good connection. There we go. 0.2 ohms. Exactly. Alright, which is a 1 over here. PZT negative. Cool. So far, so. Now we're going to move over to the thermoelectric cooler for the resonant cavity. So it's these two wires right here, right next to those, which will be the yellow and the white. So let me show you. These wires right here. Go over to the yellow and the white wires in there. The red goes to the white and the black goes to the yellow. Let's figure those out. And we'll call those RCT for resonant cavity. And those will be listed appropriately on the printout. Okay, find a Sharpie with the center tip. Perfect. Alright, first I'll be doing the positive. Get in there with the multimeter lead. Just like that. Point 2. Alright, that should be it. Let's look for the 2.2. That one right there. Okay. So this one is going to be white wire. Oh, I'm on the white wire. Okay. That's positive. Okay, so PT. Let's mark RC T plus. RCT plus, good enough. And then the negative for that. Over to the yellow, which is two. .2, okay. Which is that one. RC T minus. Double check that. That's correct. Cool. Okay, so we have 6 connections that will be remaining. 1, 2, 3, 4, 5, 6. Let's see which ones give us the 15K for the thermistors. So let's start with these lower 2 here. Nada. Nope. Now we got 12K over that one. Okay, so I'm betting the other one's going to be the inverse. Give me us 12K. Okay, perfect. Alright, so how they got that wired up is... yeah. So, these 2 right here are one, and these 2 right here are the other. So now we get to figure out exactly which one goes to which. And it'll be a process of elimination. So I'm going to pull these wires out here. I have measured earlier which is which a little bit, and then I've also measured the continuity between the thermistors in this one and the thermistors in here. They're identical, so let's figure out who does what. Yes. Okay. See if one of those is for that. Yep. Okay, so that one is for the resonant cavity. I'll move the meter over here. I have this connected to one of the thermistor leads. I'm going to touch over here for the resonant cavity thermistor. This is 0.2. And if I move over to here, give us another 0.2 when I touch the other lead for the thermistor. Which it does. Okay. So I'm going to put these in the diagram. So let's say RC TH. I screwed that up. Right. And the other one down here. Perfect. And now for the pump diode. The thermistor for the pump diode. Which should be these two right here. These two should be free and empty. Let's measure them. .5 meg. That looks pretty empty to me. They might be for the fan. I'm betting those are for the fan. We'll check those in a little bit. Yeah. Alright, that's the red and the black on this side. So we're going to pull that connector off. Be the two lower pins on the left hand side. So these two right here. And we'll be checking those out. So not that one, so it has to be that one. Get that backwards. I might have that backwards. I definitely have that backwards. Yeah. Right, okay, so looks like these are for the pump diode instead. So we're just gonna put that as PDATH and PDTH. Yeah. And the other two for that one, for the resonant cavity. Yeah. Okay. And then I'm gonna double check that these two are for the fan. So here's the fan. Little moth. Maybe we can get access to those fan wires. Does not look like it. Right. Oh. There is one way to find out. Stick power in there. That's not a good battery. Yeah, so many dead batteries here. So many diagnostic choices. So few of them operating. That'll work. We have 50-50 chance of cooking that fan that I don't care about. Given how it's connected, I'm going to guess that the positive is on the bottom and that the negative is on the right. Negative. Flip those around. Called it. Okay. Oh, that's positive. And F negative. Cool. We have a pinout. I'm going to get this back together and we'll move on to figuring out all the connections in the other DPSS laser head. Now that I have a pinout suitable for this connector and this laser head is put back together, we can move on to getting all the information from this laser head here. So I'll put this off to the side. And the first thing I'm going to do is find the nominal current for the pump diode on the inside. I've got this laser driver here, an ATX power supply, which will give me my 5-volt rail to run everything. So I'm going to remove the laser head that's on this driver right now. And I'm going to plug in this one. You can see just how powerful the output is on that laser head, just to verify that everything works. Connect that up. And start the power supply. You can see we get a little bit of blue, but not all too much. So I'm going to need to pull apart the back of the laser head here, get access to the wires that are going to the pump diode, and I'm going to throw in my multimeter in the current, the DC current settings. We're going to figure out what the DC current is going to this pump diode. So that's the next goal. Yeah, let's do that. I'm going to turn off the ATX power supply, just like that, and disconnect everything. Pull the back of the laser head off. This will give us access to the connections inside of the laser head, and we'll be using that to test everything. Oh, there's a bunch of wires in the back. There'll be a little reverse protection diode here, which will be for the actual pump diode itself. At least I think that's what's underneath there. And yeah, looks like it. So should be the negative and the positive of the pump diode input. Let's go ahead and check that out. I'm going to remove the heat shrink on the reverse protection diode. That way we can get a voltage reading. Our voltage reading should be about 1.8 to 1.9 volts. And there it is. This will go across the laser junction in reverse. So if this side right here is the cathode, that's going to be the positive, and this should be the negative. It just prevents the power going backwards into the pump diode if it's put backwards. So we're going to check that out. I'll give us access to that side. And that side. So got that all available for testing. So once again, the anode should be R negative and the cathode should be R positive. So let's see if that's what we get. We're going to reconnect the laser head up to the driver. Test our voltages. That one out of the way. This will also give us the polarity of the wires that go to the laser driver, so we'll know exactly what's positive and negative for the pump diode. And go ahead and turn the computer power supply on. Alright, got a little bit of output. Go ahead and test across that diode and see what we get. As I said, it should be 1.8 to 1.9. Could be lower if it has a soft start feature. So I'm going to put this on reverse to what the diode here is marked, because it's a reverse protection diode. We should get positive voltage here. Let's see what our reading is. 1.7. Okay, so just under the 1.8 range I would expect, and this is indeed positive voltage. So it looks exactly where I would expect it to be. Okay, now that we got both the voltage and the polarity, we can now check the current of the laser diode. I'm going to go ahead and power off the laser head. And our wires are going to be the green and the white here, and the red and the blue here. So the red and the blue is going to be the negative, the green and the white is going to be positive, according to what we see. I'm going to go ahead and I'm going to disconnect the, what should be the positive side. See if I can get in there. Disconnect it from the laser driver while I work on it. Tight squeeze. I should be able to get into that, so I'm going to desolder it. I'm going to get my wires out so I can connect those to the multimeter and solder the multimeter in series with the pump diode. Wires. Alright, so inside we're going to be soldering the multimeter onto that little tab right there and onto this set of wires here. Now since I see 1.7 volts and this is a 2-watt laser diode, I think the max is 2.4 watts for the pump diode, I expect to see a current range of about 1.7 to 1.8 amps. I don't think it's at the full current it can support, so I expect to see it not as high as it can go. Its upper current range should be about 2.6-ish amps. I don't know if I'm going to push it up that high, but we'll see what happens. Maybe at least push it up to 2.4 if I can. Seems like a safe range. So, side will go on the group of the wires. Solder. Alright, now we're set up to get our current reading. So DC, I'll put that in 1. That should be our negative return, and that should be our positive return. And we'll see what current we get. Or we'll get smoke. One of those will happen. I'll fire in my laser. 1.9. Okay. That's pretty reasonable. Okay, so we know our nominal current for the pump diode then is 1.9 amps, which would definitely indicate that this is a 2-watt pump diode, given that it's about 1 to 1.1 amps per optical watt. I'm going to mark that down. Pump diode current is 1.96. PDC 1.96. Got that listed here. Okay. I'm going to resolder that connection now that we have that measurement. And we should be done with the driver. So, put that off to the side. That's pretty much the only thing we needed that driver for. Now to reconnect the wire feeding to the pump diode. Looks clear. reheat shrink that diode. And now we can press that back in. All these wires are also different colors. That'll be important. And one last run just to make sure that everything is put back to where it should be. If the red wire is connected better. All right. Yep. Looks well, looks as good as it's gonna look, given the laser's health. Cool. Off you go. So the next step now is to get inside of this laser head and start figuring out the wire coding for that. We're going to do that a lot less invasively as we did with the bad green laser head. Of course, we don't want to cause any damage to anything in here, so the little trick I'm going to use, and get to that in a little bit. I've been inside of this laser head before, monkeyed around with it. I put in a new LBO, and it did a little bit better, but still not quite the performance I want. And that could be a lot of things. It could be that the temperature of the driver there is not set correctly for the resonant cavity. Also be a bad pump diode and or whatnot. So we still may not be able to get excellent performance out of this, but we'll see what we can get. So inside here, it's basically the same exact layout as we had in the other laser head. Those same 5 components. We've got a thermoelectric cooler underneath here for the resonant cavity. We have the little thermistor here for detecting the temperature of the resonant cavity. We got the pump diode assembly, and the pump diode assembly has a little thermoelectric cooler underneath here. Probably can't see that. And then it has a little thermistor in the back, which you can see goes through these 2 wires here. So let's try to figure out what the pinout is. In the meantime, in between time, what I'm going to do is I'm going to just lightly put the cover back on so we don't get any dust on the inside of it. While we take the connector off, because we won't need that connector anymore. Okay, we already know that some of the wires are for the pump diode. It's the green and the white and the red and the blue. So take a look at the green and the right and the red and blue. We're going to separate those off. And we can pretty much just take everything off and just solder it. From there, we'll work out what wire goes to what. So white doesn't seem to be connected to anything. So that should be shared with the green. So let's go ahead and test the continuity on that. See if that's the case. Here we go. And we should get 0 ohms if that is the case. Oh, not the same white wire. Okay, well, it's a spare wire. So it's got to be the grayish wire, maybe. Could be. We'll find out later. Get out of here. Okay, we should have 12 wires. So 4 of those will go to the pump diode. And then we should have 8 wires for the other one. Actually, we should have 15 wires. 15-ish wires. 15 or 13. I think 13 might be right. So let's give a count. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 wires. Let's figure out what goes to what. Let's first find the 4 for the pump diode. Once we find those 4, we're going to solder them together so that way ESD won't cause problems while we figure out the rest of the wiring. So we're going to look for the green and the white ones and match. I said this one didn't seem to match the green because it could be, yeah, no, it's the lighter green. Okay. Yeah, they're open, so it's going to be this one. Yep, okay. So these will be for the pump diode positive. And double check. Yep. And the red and the blue for the pump diode negative. So we have this lighter pink color. I definitely do think it's going to be that darker red on the blue. So is it the pinky one? It's a pinky one. Okay, so should be these two. Let's go check. Get out of there. Nope. Go ahead and check this one. Well, it's one of those. Oh, yeah. I've seen better wire. Yeah, it's definitely not that one. What the damsel? Oh, orange. Is there an orange? There is an orange. Let's try orange and blue. Yep, those two. Okay. Those will be for the pump diode negative. Right. Alright, and then, as I said, I'll be soldering these two together just to make sure there's no issue with ESD. The white was an unused wire, so we should have an even pair left. Looks like we don't. So 2 of these will be for the TEC. Oh, we'll figure that out. It'll be fun. So let's start figuring out what to pin out of these other wires are then. Let's mark out what colors we have left. We have white, W, yellow, brown, black, pink, and dark green. I can just have it green because it's the one that's left, and then we have red, orange, and purple. Now we get to seeing what goes to what. Alright, to do that, I'm use this very tiny needle to probe the wires. So I don't want to break any of the heat shrink or have any loose wires exposed inside of the laser head. So one end of my meter is going to go onto one of these wires, the other end of the meter is going to go onto that needle. I'm going to sit there and I'm going to poke the wire, get a connection, figure out what wire goes to what, and label them here on the paper. Now, bring it up so you can see what I'm doing a little clearer. I use the meter for testing that continuity. Get those wires out of the way. And now we can go hunting. Let's go hunting for the white wire first. Actually, what we're going to do is we're going to start inside of the laser head. So let's see what we can see as far as the connections between these just off the bat. So get some of these knocked down. Let's see. So dark green is laser diode TEC. Yes. Go ahead and test that. The wire, stick it in, dark green laser diode TEC positive. Yep, okay, so LDT positive, dark green. Next, let's see what the negative is. So that will be what looks to be the yellow. Let's go ahead and check that. So insert the needle into this connector here. Test out the yellow. Yep, okay, so that's a negative for the TEC for the pump diode. No. L, D, should list so it's just PD, but I know what I'm doing. LDT, negative. We got the thermistors for the thumb diode. Let's see if we can trace where those go. These two wires here. Yep. Boy, those are a bit hard to trace on the other side, aren't they? Oh, let's stick needles into those. They are quite tiny wires. I think I got it. Let's see what wire it is. So, laser diode thermistor. See what we get. What color are you? Start with W. White, brown, looks to be brown, so LDTH, yeah, put PDTH, and see what the other one is. Alright, let's start with blue. No, it's not blue, huh? It's black. Not black. Go over to the pink. Not pink. Try the red. It's the red. Okay. B, D, T, H. Now the other things to find out are the wires for the thermoelectric cooler for the resonant cavity and the thermistors for the resonant cavity, which will be the white, the pink, the purple, and the black. No, this will be the negative for the resonant cavity thermoelectric cooler. Stick a wire in that. I'll bet you that's going to be the black. Let's find out. Let's go with a hunch. Test the black. Nope, not the black. Let's try the white. Huh, well, that was the one that was disconnected. No wonder why it wasn't working. The thermoelectric cooler for the resonator was disconnected. It wasn't even finding proper temperature. Explains a lot. explains a weak output. Let's just make sure that the other ones aren't part of that. No, purple is also connected, so, okay, so 0.1, 0.3, okay, so one of those is the positive, one is going to be the minus, so I'm guessing that's going to be the TEC positive, the white, and the purple going to be the TEC negative. Is that purple? Okay, so I'm going to list the purple wires, the TEC negative. So R, C, T, negative. And we'll go over to the positive, which is over here. Which we have the white, the blue, and the pink left. So let's start off with the pink. And the pink is 0.2. Okay, the pink is 0.2. Then the purple should be 0.3. Which it is. Okay, so the pink is positive for the TEC for the front resonant cavity. So let's that down. Pink R, C, T, positive. That just leaves us with the white and the black. So for giggles, let's see what's across the white and the black, and I'm betting that's going to be around 15K to give us the thermistor for the laser resonator. So let's see if we get 15K in there. Oh, we do not. Oh, we do have, what else left? Yeah, what else do we have left? Let's see what goes where. Something may be joined. Oh, we may have to undo that. Alright. See where that connects to. It's not the white. Try a black. Doesn't seem to be black either. Okay, let's try the green and the red. See if those are joined. See. 1, 2 mag. Where do you go, Dave? So far, absolutely nowhere. Alright, let's try this again. Try the black. Nope. Try the white. Nope. Oh, it is the black, okay. Alright, so black. RCTH. That leaves us with just the white. So the white has to be that last connector. If it isn't, it surprises me. It's surprising that white wasn't connected. No. Okay, well. Let's try the green. Let's try the pink. No, not any one of those. That's strange. Try and get a better connection on that again. Yeah. Come on, you have to connect to something. And it connects to the brown. We already used the brown though. Yeah, the brown connects to one of the thermal regulators up here. So I do it this tied together. Certainly doesn't look like it. Brown, yeah. So, yeah, what does the white connect to? Interesting. Go ahead and retest those. Yeah, brown connects to there. And brown connects to here. Sure does. Okay, so the white that's for the ground. Okay, well, now we know what the white does. So the brown links to two things. Is there a little jumper here? Could be. Let's go and investigate. Now we'll end up pulling the white wire off and using it for separating out those two thermistors. First we're going to see what the link is. Alright, so brown wire links over to this one. Okay. So you can see that little loop of wire here. So we'll disconnect one of those. Let's see what looks to be what. I'd say the one over to this side is for the TEC. So let's make that white for the other end of the thermoelectric cooler. Actually, no, we'll be making this side the one for the thermoelectric cooler. Okay. Right, chop that off. Which will leave us with this wire right here. So brown is TEC. Not TEC. Brown is the resonant cavity thermistor. So what? Brown. RCTH. And I will make the white one the pump diode thermistor. Which will be this right here. So let's go ahead and desolder that. And throw the white wire on there. Go down, you heathen. There you go. That's satisfying. Alright, so now we should get 15K between the white and the red. R is for red, yes. Okay. 15K between the white and the red. Double check. Which we do, just about. And then between the brown and the green, we should get that same reading. Brown and the green. Here, RGT, red, PD, green, pink. Oh, brown and pink. Let's see. The white went PD, so PDTH. BDTH. Brown RCTH. Black. Okay, so brown and black should be. Okay. Got it. We have our pin out. The next step is to start connecting the laser head to the new laser driver connector. And this gets a little interesting. At this point, I'm ready to start soldering the wires onto this connector. I have this wire here, so that way I can test the current on the pump diode a little easier. I have my complete sheet that tells me what the pin out of the connector is. Keep in mind everything is going to be reversed. It's more of a reminder to me than it is to you, because if I screw this up, I'm out of laser. Got all these trimmed down and tinned, ready to connect onto that. And I've already checked the 4 thermoelectric coolers, the 2 in each laser head, to make sure that the polarity is the same and they all cool down when positive is connected to positive and negative is connected to negative. So let's start in with some of the soldering. I'm going to start by soldering the pump diode and the thermoelectric cooler and the thermistor for the pump diode. I'm going to not worry about the resonant cavity for that laser right now. I also have my camera here that's modified to see IR, so I'll be able to see if the pump diode is operating properly. So first wire is going to be the pump diode positive. Actually, let's see the pump diode. Yeah, let's do that now. Pump diode positive, which is going to be the green and the white. A little bit of heat shrink on that. And that's going to be the top one here. A little bit of solder. Perfect. And I'm not going to heat shrink it quite yet, but we'll get to there. So this will be where I put the multimeter to test the current when I get to that point. Next is to connect the pump diode TEC. See, negative is on that side and positive is pump diode T. Pump diode T, so plus is up here, right above the positive for the pump diode. So positive for the TEC is pump diode T, negative pump diode T. Okay, so that's green. Take the green and put it up on the top. And the negative is going to be over here, so off to the side, which is going to be that one. And that's going to be the yellow. Yes, yellow. Okay. Next is the pump diode thermistor. PD white and red. So it should be these two. We can re-verify that. Make sure that we have around 15K across those. Which we do. Alright, so PD thermistor, one goes over on, oh, this is all reversed, isn't it? Gotta undo those. Alright. Let's avoid accidents. Yellow negative. Yep, PDP negative. Okay. Pumped out thermistor. So on that side, those are red. We'll go on the lower one right here. Turn around to the side. Okay, and then on the left side over here for the white. Looking at it this way. Okay. So that's all of that. It looks properly connected. I have the laser driver set to 300 milliamps, so we can test to see if we get any IR output. So join that to the negative. Double check everything. So it's on that side, that side. Looks good. Let's see what it does. We should have some infrared coming out, and the pump diode should be properly cooled. So the magic words should be make sure none of the other wires are touching. Looks good. You have the power wire. I'll open that up. We're going to look for infrared light. So I'm going to turn off the light. Log in here. That way you can use the camera. light off. Here goes something. So yep, so you can see a little bit of the infrared coming up right there. Looks perfect. See what's cooling that down. And it's keeping that under proper temperature. So far, so good. Okay, we're going to disconnect it, and that all seems to be working as it should be. No complaints there. That pump diode is getting pretty chilly, so I don't want to run it with the cover off, otherwise moisture is going to collect on there, and I'm going to ruin the pump diode. So that's all I needed to check. And then we'll connect up the resonator, and then we'll set the pump diode current to 2 amps. After that, we can mess around with these settings inside of the driver that handle the temperature of the resonator. So, finish connecting those things up. Alright, next let's do the resonator thermoelectric cooler, which is going to be the pink and the purple. So RTC Plus, which is the pink. RTC Plus pink. Okay, so it's going to be the one on this side right here. Actually, you know what? We can set the pump current now before we solder everything else back together. I am going to close the laser diode, make sure, the laser head, make sure no moisture can get in, or at least keep the moisture down. If that's the right bit. There we go. Set it for 2 amps. This laser does have a soft start, so it takes a little while to kick on. Plug that back in, and solder my meter in series with the pump diode. And we'll set that. Set that there. Perfect. Alright. So far, so good. There. Let the games begin. All right. Plug it in. It should come up to 300 milliamps. So 0.030 on the meter. Wait a little bit till it does that. And then we'll set the peak current. So there's 4 potentiometers in here. This one is for the max current, this one is for the minimum current. And these are for the temperature. Oh yeah, 300 milliamps, we already hit that. So I'll be adjusting this one. Once again, it has a soft start, so I have to watch the rise on the current as I turn it up, because it's going to be a little delayed. Here's hoping that thermoelectric cooler is doing its job. And we won't get any output until we set the resonator temperature to its ideal temperature range. So let's flip to standby. 300 milliamps. So 7. 1 amp-ish. Let it cool down a bit, make sure everything is not overheating. Okay. Keep going. Let it set a little bit again, and then we'll bring it up to the full 2 amps. I just want to make sure that the soft start has had a chance to fully kick in. That way we don't have to worry about overcurrenting the pump diode inside of the laser head. Alright, here we go. 1.75, let's set it to. Shut her up. And let's bring it up to 2 amps. And then we're up to 2 amps now. Looks good. See a little blue dot right there. So far so good. Alright, with the current set now, I'm going to turn everything off. We can finish the wiring and connect the rest of the stuff up. So I'm going to very carefully negotiate getting the pump diode negative in where it needs to be. Remove that for the time being. I disconnect that and heat shrink. Here we go. Rubbish connection. Solder. Perfect. All right. Reconnect the red here, which was the thermoelectric cooler. And now we can connect the thermoelectric cooler and thermistor for the resonator. See what we get by messing around with the resonator temperature. And maybe the pump diode will bring it up to the full 1.8, 1.85 volt range. You shouldn't calibrate a pump diode based on its voltage, but there's a certain voltage range that you can watch for, and the current regulating just makes sure that it doesn't take more current than it should at that voltage. Alright, no. What do we connect now? RCT plus. So plus is going to be the pink. Yeah, pink. So that goes on this side. BDT. BDT plus green. Easy. RTC negative. DC negative over to here. Okay, what have I done? Red wire, what's that red wire? Red wire is green RRTC. Yeah, thinking is fun. PD power. White and green. No. Blue. Ah, okay. I see what I did now. That shouldn't be there. Should be one under. Nope, nope, that was right. What am I doing? You can never double check your work enough times when working with lasers. Just can't. Alright. RTC. Plus up here. That's right. And this leaves us with these two. And one of those will go down here. And the other one will go into that one. That all seems right. So, this is what I've got. Come on. There you go. This is what I've got. It looks correct. It looks correct. Cool. Plug it in, plug it in. Here we go. We'll see what it does. I want to make sure that there is no thermal runaway on the pump diode. Just make sure that's properly cooled. Got a little bit of blue already. It's a good sign. Phasing it out, also a good sign. Temperature's fine. That's a little warm, as it should be. check the infrared on that. Oh yeah, no doubt about that. Got a lot of infrared in there now, and that's the dangerous bit. Remember, laser, look at source, erase retina. Cool. Alright, well. That's fine. Let's check our voltage on that. See what the pump diode voltage is at this point. We'll go ahead and set our resonator. 1.9. That seems a little high to me. It should be fine. Alright, looks like everything is working properly thus far. So, now I'm going to adjust the thermoelectric cooler for the resonator. Let's see if we can get any better output on that. Gear 1, gear 2. Should be this one. I am concerned about that pump diode being so cold right now. I really don't want any condensation on that at all. Oh, it helps to put a screw on that. It really is at this point just seeing what the temperature ranges will do, and setting the temperature ranges can take quite some time. Alright, I've set all the temperatures correctly and got this whole thing back together. Finished up the connector here so that way it's secure. It looks good. There is some damage on the second harmonic generation, the frequency doubling crystal on the inside. Sometimes the optical coatings just tend to wear out. This one is the one that I pulled out originally. As I said in the video, I messed around with it, and the coatings on this crystal aren't that great. So We're not going to get the full wow brightness that I would like to get out of it, sadly, but if I do find another crystal to put inside of here, it should look great. I couldn't be happier with how it turned out, to be honest. Everything went by the book. Let's plug it in and see what it looks like. So, right now it's warming up. I'm going to turn off the shop light. Yeah, look at that, that's fantastic. This camera does not do the color justice at all. So I'm going to switch cameras real quick so we can take a better look at that and get more of an idea of how it actually looks. Using this camera, it definitely looks closer to the color and the brightness of which I see it at. Yeah. Oh yeah, it's definitely closer to the 473 nanometer color. That went together really well. Yeah, let's take a look at see what it looks like on the other side of the room. Pointed at something white. Let's see. Oh yeah, that'll work. Alright, let's take a look. Off the light. There's the beam. Not bad at all. I get a little bit more plug in here. Yeah, not bad. Not bad at all. Well, I hope you found this video helpful, and I was pretty thorough about how to check all the wires and connections and stuff like that, so that way you can do this with your own lasers on your own. Now keep in mind, this is a pretty simple DPSS laser head. It only has 2 thermoelectric coolers inside of it. Some lasers have more, but I thought this would make a good introduction, since I will probably be working with more complicated laser heads in the future. I hope you enjoyed this video, and as always, stay tuned for more.